Hey there, welcome back to our channel. Today, we're going to create a hexagon plot and a scatter plot to explore the relationship between age and net income. Hexagon plots, also known as Hexbin plots or hexagonal binning plots, are a type of data visualization used in statistics and data analysis. They are particularly useful when dealing with large datasets or continuous variables where individual data points may overlap, making it challenging to interpret patterns. We will generate a hexagon plot using both the Hexbin package and ggplot2 package. So, let's get started. First, we're going to clean up our workspace by closing any open graphics windows and clearing all variables. This ensures we're starting with a clean slate. Next, we're going to load up some necessary packages. These include Haven for data import, Hexbin and ggplot2 for plotting, and dplyr for data manipulation. The dataset used in this example is sourced from the German General Social Survey. To download this dataset, follow these steps. Visit the provided URL. Scroll down and locate the All Bus Accumulation link. Click on the link to open a new window. In the search box of the new window, type ZA3762 and press Enter. Click on the Research Data button. On the right side of the page, navigate to the Downloads section. Click on Datasets to access the available formats. Select the desired format, such as Stata data with a .dta file extension. Ensure that you are logged in to your account. The dataset file will then begin to download shortly. Now, let's read in our data. We're using a dataset stored in a .dta file. Once we've loaded the data, we'll take a quick look at its structure to understand what we're working with. First, we're checking how many rows and columns we have in our dataset using the dim function. The dataset has 2,946 rows and 899 columns. Then, we're listing the names of all the columns in our dataset using the names function. The column names range from V1 to V899 and contain various variables or attributes of the data. Finally, we're opening up a new window to view the entire dataset. This helps us get a comprehensive understanding of the structure and content of our data. We can clearly see the information for each variable under each variable name. We're particularly interested in two variables, age and net income. Let's take a closer look at these. The unique function for age variable returns all unique values like 41, 49, 74, and so on, spanning a range of different ages. Similarly, unique function for net income variable returns the all unique values for the net income of individuals and label information. Next, we're going to create a new data frame with only these two variables. We will create a new data frame called New Data containing only the age and net income variables from the dataset we imported earlier. We did this by selecting columns V473 and V686 from the original data frame, grouping the data by these two variables, and then filtering out any rows where the net income is less than 10,000, excluding potentially invalid observations from the analysis. Now that we have our new data frame, let's take a peek at the first few rows to make sure everything looks good. For this we shall use the head function to print the first 6 rows of the dataset. Now let's create a scatter plot. This will give us a visual representation of the relationship between age and net income. We will utilize the plot function, setting age on the x-axis and net income on the y-axis. The title will be defined using the main argument, while the x and y-axis labels will be specified using the xlab and ylab arguments, respectively. Additionally, we will set the point size in the scatter plot using the sex argument, which is set to 1. Next, we're going to create a hexagon plot. This type of plot is great for visualizing the density of observations. Darker hexagons indicate a higher number of observations in that area. We used Hexbin package to visualize the relationship between age and net income. The plot is set to display net income on the y-axis and age on the x-axis, with a color scale style. Additionally, the plot includes borders, has an aspect ratio of 1, and uses a square root transformation for the x-axis values. Finally, we're going to create another hexagon plot, but this time we're using the ggplot2 package. We start by specifying our data frame and mapping the x-axis to ages and the y-axis to net income using the aesthetic function. Next, we add hexagon-shaped bins to the plot using geometry_hex function, with 20 bins and a black outline color. To add color to the plot, we use scale fill gradient function to create a gradient ranging from light green to dark green based on the density of data points. For the x-axis, we apply a square root transformation using scale x continuous function to better display the data distribution. We then set the labels for the x and y axes, as well as the title and subtitle of the plot using the labs function. Finally, we apply a black and white theme to the plot using theme_bw function for a clean and simple visual presentation. Looking at these plots, one can see that almost all individuals have a net monthly income of less than €2,000. Only few individuals earn more than €6,000 per month. Interestingly, the highest net income recorded is $8,000, which is for an individual who is 62 years old. That's it for today's tutorial. We hope you found this helpful and learned something new. Stay tuned for more our tutorials and don't forget to like, share, and subscribe. Happy coding!